this video, I'm sharing my academic experience of the past 2 years so that you can make a better career choice for yourself. Whenever making a career decision, the first question that comes to a person's mind is the scope of that field. So the scope of electrical engineering is always fluctuating because it is always in competition with the other engineering fields in the market. What I will suggest you is to make your career decision based on your interest and career goals. So now let's dive deeper into this video and discuss what I have studied so far in my degree so that you can decide if you are really interested in these subjects. So let's start with first semester. So the courses that I studied during the first semester were linear circuit analysis, fundamentals of programming, and applied physics. And all these courses are fundamentals of what electrical engineering is. The other courses include workshop practice, English language, and calculus. Calculus 1, it was a course that was entirely related to mathematics. There was another. So let's start discussing these courses one by one. First of all, we are discussing linear circuit analysis. So here we go with the definition of linear circuit analysis. Linear circuit analysis is majorly about figuring out voltages and currents in different components in a given circuit. So the major methods that we are going to be using for linear circuit to solve circuits in this course are nodal analysis, mesh analysis, superposition, and source transformation. All these methods are based on Ohm's law, that is V is equals to IR. You must have studied this law in your intermediate as well. Okay, now to have a better understanding of this course, let's type linear circuit analysis here on the search bar and let's go to the images now. So let's pick one circuit. For example, let's have a look at this circuit, right? There are different components in this circuit, like there are these resistors and this is your power supply. So what you're going to be doing is you're finding, see there it is written that the current flowing through this resistor is 5 amperes and the voltage across this power supply is 28 volts, right? So that's what you're going to be learning about in this entire course. You are going to learn to find the unknown quantities like current and potential difference across different components in a circuit using the 4 techniques that we discussed before. This is another circuit. In this circuit, these two, this one is your dependent source and there are many other circuits given here. So using this, I hope you can have an idea of what this course is going to be about. Now let's discuss the second course of first semester. It is fundamentals of programming. So let's go further into this video and let me share what you're going to study in this particular course. In this course, you will be introduced to the world of programming for the first time and you will learn most probably C language and C++ and you will learn to write this first code in your first programming class. And let us just quickly write that code here. This is the simplest code in any programming language where you learn to say hello to the world of programming. And here you go, you have your results. This is the first code that you will be trying in your first class, and then from here onwards you will be introduced to a whole new world. And so the next course that I studied during the first semester is applied physics. Now I will give you a brief introduction of what I studied in this course. In this course, you will learn about electrostatics and magnetism, where electrostatics is the study of stationary charges, and you will also learn about force and motion and laws of motion that you are already given an introduction of all those things in your intermediate, but you will mainly focus on problem solving. However, in this course, you will learn about rotational motion as well. You will solve problems related to centripetal force and Earth's rotation. So in this course, you will also learn about harmonic motion, that is F is equals to kx, where F is the force applied, x indicates displacement, and k is your spring constant. particular section. And for when you enter your circuits lab for the first time, you learn how to plug in a resistor onto a breadboard for the first time. Then you will also learn how to glow an LED for the first time, and all of this will be such a new, unique and exciting experience for you. So now let's discuss second semester of an electrical engineering degree. The courses I studied during the second semester were electric network analysis, engineering mechanics. This course was related to physics. Then there was communication skills. We will not discuss this course in detail since this is not related to that much related to electrical engineering. Another course was linear algebra and ordinary differential equations. This course was based on maths. There were some other courses as well, like engineering drawing and Pakistan studies, but we will not discuss those courses because again they are not very much related to electrical engineering. So for the course of electric network analysis, you will be using this book, Electric Circuit Fundamentals by Sergio Franco, and I use this book for both the courses, that is your linear circuit analysis and electric network analysis. If you pursue electrical engineering one day, then in your linear circuit analysis you will study this section of the book, and then in your next course, that is ENA, electric network analysis, you will study this section of this book. Now the chapters that you're going to study in this section is chapter 9, that is transient response of a second order circuit. So let's see what this chapter is going to be about. So see, there are four major sections of this section. The last section 9.5 we did not study that, so I'm not going to be explaining that section. I'm trying to give you an outline of this course so that you can have a better idea. So the first section that you will study is natural response of series and parallel RLC circuit. Here this R stands for resistance, L stands for inductance, and your C stands for capacitance, right? So there will be RLC circuits in which you will have a resistor, an inductor and a capacitor, and you will be studying natural response of series and parallel circuits. So I hope that you know what series and parallel connections are. See, even if you don't know, I will be explaining them in a bit. So in the second section of this particular chapter, you will be studying transient response of second order circuits, and from here onward, from this section, you will be basically focusing on the AC circuits, right? And then step response of second order circuit and second order op-amp circuit. So in the fourth section, you will have op-amps in your circuits as well. So let's go down now and have a look at the circuits. So for example, this is a circuit that has this Vs source for the later courses as well. So let's have a look at another chapter now. So the next chapter that you'll be studying is the concepts that you will have learned in the examples above to solve these questions. So this course is basically entirely So now we are discussing linear algebra and ordinary differential equations. The overview of this course is given here. So first of all, in this course you will learn about matrices and about linear algebra. So in this section you will learn about addition, subtraction, multiplication of matrices. You will learn about Gauss-Jordan method and Gauss elimination method. By the way, I have already explained all this on my YouTube channel. So I will leave a link of that in the description box, so you can go check it out if you need help with that and if you're already an engineering student. Moving forward, you have your vector section. In this section you will be studying vector spaces and subspaces, eigenvalues and eigenvectors. Now coming to first order, I have written ODs here. So this OD simply stands for ordinary differential equations. So whenever you're talking about first order ordinary differential equations, and when see in the next section I have written ordinary equations of higher order. So what is the difference between the first order ordinary differential equations and differential equations of higher order? So let's first go and see that. So I have simply searched for first order ordinary differential equations, and let's have a look at one of them. And so for example, let's have a look at these equations, right? And on the other hand, let's open this second order ordinary differential equation. Now in the second order ordinary differential equation, you can see that the highest power of the derivative is 2, right? So this is higher order ordinary differential equation. On the other hand, in this first order ordinary differential equation, the highest power to this dy by dx term, to this derivative term, is 1. So this is first order ordinary differential equation. And so you are going to learn about homogeneous equations in first order ordinary differential equations. And homogeneous equation is simply an equation in which the right hand side is equal to 0, and a non-homogeneous equation is an equation in which the right hand side is non-zero. So I have made a lecture about homogeneous and non-homogeneous equations as well, so you can check that out on my YouTube channel as well. Then you will be learning about exact equations and integrating factors. So you find out whether an equation is exact or not by taking partial derivative of that equation with respect to one variable, and then you take partial derivative with respect to another variable, and if the two partial derivatives are equal, then you say that the given equation is exact. So that's what you do. That's the simple maths, right? So this is a mathematics course, so you are going to be studying things that are related to purely mathematics. Then you are going to study ordinary differential equations of higher order, and finally you will be studying non-homogeneous linear equation. In this you will study Laplace transform and inverse transform. It looks somewhat like this. So this is what you're going to be studying in this. It involves integration. For the circuits courses, you will be using this software that is called Proteus, and on this software you will be basically simulating the circuit before actually drawing it on breadboard. So we discussed the LED glowing circuit before in this video, so let's just simulate that circuit first of all. So I have just simply picked up some items here. So what you can do is you can just plug in a voltage source over here, and let's change the voltage of that source to maybe 6 volts, and then you can plug in a resistor over here. There you go, and it is a 10k resistor, and I think that is fine. Then you can just put an LED over here like this, and then you can connect all these components using a wire. So what you're learning here, you will be, first of all, for any design, you will be first simulating that design on this software, and then once you're done simulating it, then you will actually draw it practically on your breadboard, and in this way you are going to be designing complex circuits later as well. So there you go, you can just connect all these components using a wire. And now okay, here you can see I have changed the 10k resistance to 1k. Now you can just run it, and you can see your LED is glowing right now. So this was your LED. Now it looks somewhat like this. You can also connect a voltmeter here. So in this way you can connect a DC voltmeter over here with the LED, and then you can see the voltage appearing across the LED. So let's do that now. You can see that the voltage appearing across this LED is 2.14 volts. So you are going to be simulating all your circuit designs first of all on a software, and then you are going to be actually making them on your hardware. So the courses that we are discussing in this semester include digital logic design, technical and business writing. We are not going to be discussing this course in detail since it is not entirely related to electrical engineering. The next course is vector calculus. It is based on mathematics, and then we are also going to be discussing object oriented programming, and the last course that we are discussing in this video for third semester is thermodynamics. In this course, you will learn about interconversion from one number system to another. First of all, you will learn to convert decimal number system to binary number system, and then you will also learn interconversions between hexadecimal, octal, and binary. Then you will learn about logic gates like AND gate, OR gate, XOR gate, XNOR gate. You will be solving different questions of Boolean algebra using these gates. Moreover, in this course, you will learn to convert a complex circuit like the one given on the left to a cost-effective circuit given on the right. By the way, I have already created a course on digital logic design. You can go and check it out on my YouTube channel. So in vector calculus, first of all, you will learn about lines and planes, and you will solve different questions related to that. Then you will be solving questions related to vectors in these three different coordinate systems. First of all, you will learn about XYZ rectangular coordinate system, then rho, theta, and z, that is your cylindrical coordinate system, and at last spherical coordinate system, that is rho, theta, phi. Then you will learn to draw different traces like XY trace, YZ trace, and XZ trace of different quadratic surfaces. For example, you will learn to draw XY trace of parabola and other traces of ellipse and cone and other such quadrant. So in this course, you are also going to be focusing on programming in C and C++, but your approach will be related to classes and structure. Let's learn object-oriented programming a bit on Visual Studio. So first of all, I'm going to create a class. Let's call this class Electrical Engineering. So there you go, you have created your class. Now inside that class, you're going to place this parenthesis just to show that this is a class. And then inside it you can use this public keyword. It is usually used for functions. Now we discussed fundamentals of programming course before this, so in that course you must have already studied function before you come to this in your degree program. So here let's just create a variable. Let's give it type character, and let's call that variable engineer maybe. And then you can also create a function over here, void print. Let's call that function print, and inside that function you can print that I am eager to become an electrical engineer, and maybe you can then add end L here just to end this line. And in your main you will be creating an object of your class. Since you are learning object oriented programming, I don't want you to actually learn anything in this video. I'm just trying to give you an idea of what you're going to learn. And let's write a here, and then you can just call that function print over here. And now let's go and run this. So now you can see that you have on your output screen, I am eager to become an electrical engineer. So that's what is printed on your output screen. You will probably use a software like Desmos to learn different graphs in your mathematics courses. So for example, let's create a graph of x square here, and you have your graph. This is a parabola, as you can see. So you can create different graphs on this software. So the courses that you're going to study in this semester include electronic devices and circuits, engineering economics, microprocessor systems, electromagnetic field theory, and complex variable and transform. In the course Electronic Devices and Circuits, you will be focused on designing circuits that involve diodes and transistors. So you will be designing and solving problems with these three elements involved in them, that are diodes, BJTs and MOSFETs. So you can also see the pictorial representation of these elements. In diode there is a positive side indicates anode and the negative side indicates your cathode, and BJTs are bipolar junction transistors and MOSFETs are a type of field effect transistor. In this course, a lot of concepts of vector calculus will be used, and in this course you will learn, first of all you will revise different Cartesian coordinate systems, right? Cartesian coordinate system and cylindrical and spherical different coordinate systems. Then you will learn to find electric field using Coulomb's law and Gauss law. Then you will learn to find electric potential from electric field, and this is a very conceptual and interesting course. In this course, you will learn assembly language. You will start with simple commands like move LW and move WF. Then you will learn about microprocessors in detail, and then microcontrollers as well. In this course, first of all, you will revise complex numbers and their properties. Then you will learn about Cauchy-Riemann equations. Then you will solve problems related to line integral. Then you will learn about power series, Taylor series and Lorentz series. Later in this course you will learn about Z transform and Fourier transform.